you are welcome to today's class. Today we'll be looking at Green's theorem and some other aspects of the course. So let's look at it. Can you see my screen now?
Yes, sir, you can see it.
Yeah, for Green's theorem states that if, let's write, if two function u s comma y and v s comma y and please mute yourself, partial derivative are single value and continuous over a plane region R, over a plane region R, bounded by a closed curve C. Then integral, close integral u dx plus v dy is equal to double integral region dv dx minus du dy ds dy. So let's look at example one, number one. Verify Green's theorem. In xy plane for integral close integral xy plus y squared dx plus s2 dy, where C is the closed curve where C is the closed curve of the region bounded by y equals to x and y equals to x squared. And y equals to s squared. But in this case now, how do we sort it out? It is very simple. All we need to do is just to apply the same principle that we've been applying so far. Do you still remember exact solution? from your MTA 232. Do you still remember? So solution. We have integral of closed curve u dx plus v dy is equals to integral r dv dx minus du dy ds dy. So in this case now we have this angle, we have this. Let's get this understanding. So at this point, the point of meeting point, we have an extension. This place is at this point is 0, 0, 0, 0. So when there is extension, but before the extension, we have at this point y equals to x. But when there is extension here, you have y equals to x squared. So we can trace this one to 0, 0. This one will be can be 1, 1. Now that we have this, we can then go ahead and solve the problem. So if you look at this, integral of close integral of x, xy plus y squared dx plus x squared dy. Can we integrate this? But don't forget here, we say that our y equals to x, y equals to x squared. Remember the function here and the function here, x squared. So we need to differentiate this. But for us to differentiate it along, let's look at it. How do we differentiate this? Who can tell us what to do at this point? Yes, anybody? What comes to your mind at this point? Yes? Dorcas, what comes to your mind? Samuel, what comes to your mind?
So I'm just joining. My network is bad because it's raining.
That is why you are.
Sir. I'm just joining the lecture, sir.
Oh. Which state are you, Doka?
From Benue State, sir.
Benue.
Yes,
Samuel, which state are you from?
Sir?
Which state
Ogun
are
State,
you
sir.
now? You are in
Ogun
Ogun
State.
State now.
Yes, sir.
Oh, okay. Okay. So what we need to do is you have y squared. You have y equals to x squared along y equals to x squared. So the y dx will be 2x. Then the now asks us what is the y itself. It's going to be 2x dx. Remember that. So we go back to this equation and substitute everything there. So getting there, what do you think we could do? Anybody? You know, we are doing the substitution now. Integral C will be, remember you have x dot y. Now we know y. What is our y? Just the equation star becomes x dot x squared plus x squared all squared. I hope you are getting it. The x plus x squared dot the y is what? 2x dy. 2x dx. That is 2x dx. So which is important to say, integral of x raised to power 3 plus x raised to power 4 dx plus who can tell us plus what? Anybody? Nobody. It's clear now. You agree with me? This is x, this is 2x. Stop it. Add it together, it will give you 3x. So we can go ahead and integrate with respect to 0 to 1 from our graph here. So we have with respect to 0 to 1. So what do we have? With respect to that, don't forget you have to integrate everything, not only the s. Remember from the formula, or which one I will integrate now? Okay. So how do we go about it, please? Please, you have to talk at this point. Anybody, please? What do we do? I'm waiting.
Hello, sir. So I think we should integrate with respect to the yes. I don't know. No, I'm coming. I'm just coming in. Bro.
No, you are just coming in. It's still the same thing. We just started. We're busy waiting for you
I
guys.
think
So
integrate, sir. I think we integrate. Then they're taking note of the limits. The limits.
okay. The first
Do the
part
limit
says
of
0 to 1.
0 to 1. Yes.
The second part will say what? 1, 1 to
From
0,
the
0.
graph.
So,
Yes.
do you agree?
Sir, please come in.
I said 1, 1, 0, 0. Is that not the question? Okay, let's integrate this one. When you integrate
I
this,
didn't
what do
get
you
that.
have? When you integrate this, let's integrate. What do you have?
Oh, the network is bad, sir.
I'm waiting. Integrate it. What do you have?
Okay, sir. Oh, I didn't.
But
My
for us
network
to
is not bad.
integrate this one, remember, we need to add everything together. This plus this, open the bracket, because they are all the same. We have 3 x's to power 3 plus x's to power 4, all the x. Do you agree with me? If I now integrate this one, I have 3 x's to power 4 over 4 plus x's to power 5 over 5. 0 to 1. Upper limit minus lower limit. Our upper limit in this case is 1. So it's going to be 3 into 1 raised to power 4 over 4 plus 1 raised to power 5 over 4 over 5. When you substitute 0, everything will be minus 0. So you don't need it. So we only have 3 over 4 plus 1 over 5, which is 19. Remember, we only check along y equals to x squared. What about the along y equals to x? We have when y equals to x and when y equals to x squared. We just finished x squared now. So we now do the along y equals to x. Now let's go back to the diagram so that you understand what I'm doing. Okay, look at this. We did this one first. Let me show us. We did this one first. Now we're about to do this one now. So if that is the case, look at their points. We can go ahead and solve the problem. Y equals to x, comma, so what is the dy? Equals to what? To the x. That is the meaning. The y equals to the x from 1, 1 to 0, 0. So we are just talking with respect to what we have. So which is going to imply that integral of 0 to 1. So in this case now, if we go to our normal equation says xy plus s squared. No, let's look at it again. Plus y squared, rather. Xy plus y squared dx. So what do we have at the end of the day? We can now begin to substitute plus. Remember that from the original equation, we have x squared dy. So at the end of the day, we have integral 0 to 1. Substitute x here. We have x squared plus y squared. What is y squared? Y squared is the same thing as what we call x squared plus x squared. We know that the y is equal to the x. Anywhere you see the y, substitute it to be the x. So if you put it as the x, which importance to have this? So along the line, when you integrate it, this will be 0 to 1 after the integration and substitution, because if you look at the top, look at the diagram there, we have the diagram that says this. Then we have the one that is looking up. So here we have 1, which begins with 0. So at the end of the day, we have what we call 3 cases, which is 3x squared. That is x squared plus s squared, 2s squared plus this s squared dx. Now, if I integrate this, what do I get? I'm going to have 3x raised to the power 3 over 3. You know 3 cancel 3. You have 1 to 0, which implies that zero minus 1. Which is equal to -1. So that is what we are trying to show. Is that the end? No. Then the required line integral, then the required line integral is the required line integral is what now? 19/20 minus 1, which at the end of the day, you have it to be -1/20. So therefore, integral xy minus plus y squared dx plus x squared dy is equal to -1/20. So what we need to do is just to go back to the original equation, whereby you have, remember, original equation says what? It says integral r dv dx minus du dy dx dy is the same thing as integral r. Remember the v. What represents v here? In this case, is what? D dx, which is x squared, minus d dy x squared x xy plus y squared, or is the x dy. I can integrate this one. What do I get? Can somebody integrate this partially? Please answer, please. Anybody? Answer, please. Anybody? Should I assume you don't know it? Or I should solve it? Remember, when you differentiate it partially, what do you have? Hello, guys.
Yes, sir.
Yes, when you
We are with
differentiate
you.
this, if you are with me, then differentiate this x die x x x squared. When you differentiate it partially, what do you have?
Two x.
You have 2x. So after that,
In respect to y, the other one is xy. Since it's only y, it's going to be x that will remain. Then the other one is supposed to 2y.
which one will remain x?
The one carrying xy will remain x.
We are
Why
together.
the y square will now be 2y.
Okay.
They are together, sir.
Okay, let's do it in a bracket here so that when I write it. So when you differentiate this, you have 2x minus
Yes, sir.
s plus minus 2y.
Yes, sir.
By the end of the day, you have x minus 2y. Do you agree?
Yes, sir.
So that is where I'm going. So at the end of the day, we now have
Okay,
integral of s minus 2 dx dy. But don't forget that from the diagram that I show you up, we have x to 0 tends to 1. Then we have y tends to x squared to x. So that is their limit. Then I can go ahead and integrate this one now with this limit. The first limit will just be integral of 0 to 1 and integral of x squared to x. So it's because of the nature of where it's coming from. So at the end of the day, you have x minus 2y, the x, the y.
You're welcome, man.
So, which means, if I now integrate this one first thing, what do we do? If we integrate the first one, what do you have? That is with respect to y now. So I'm going to have xy integral of 0 to 1. You have xy minus 2y squared over 2 x squared to x, which implies this cancel this. Remember that this case now will be upper limit minus lower limit is going to be anywhere you see y, substitute x there. I have x squared minus s squared. That's the first one. Minus lower limit, which is this. S cubed minus x4. So you can see the first one is 0. You don't need to trouble yourself. Why the second one will be? You know, there is a negative here. If I open the bracket, I'm going to have integral of 0 to 1, s raised to the power 4 minus s raised to the power 3 dx. So I can now integrate this one. What do I have? I will have s raised to the power 5 over 5 minus s raised to the power 4 over 4, all 0 to 1, which is equals to 1 over 5 minus 1 over 4, which is equals to minus 1 all over 20. So what we are trying to prove here is, therefore, left hand side equals to RIS. Any question? Let's write it down.
Hello, sir.
Yes. And with you.
The last part of it, I don't know where you got x raised to power 5 over 5. Because from the initial step is a bracket s square minus s square.
0. Yes or no? Hello, Idoko. So after it, look at what I did here, from here. What I did was minus, open the bracket, minus S3, minus times minus positive. So I just changed the direction. I first of all put this one there. I first of all put this one there, then I put this one. It's still the same thing. When you integrate s raised to power 4, you have s raised to power 5 over 5. Am I communicating?
Yes, sir. Yes, sir. It is, sir.
Then when you integrate s raised to power 3, it will be s raised to power 4 over 4. Any question?
Oh, yeah. I see the leaf. No cutter. I say I will come down to see it. That was just like
Any question? So, how many of you have seen question on work done before? Okay. Let me give us example on that. Using the same method we are using, it's still the same thing. But before then, let's look at this. Idoko, are you still there?
I am, sir.
Did you understand what I did here?
Yes, sir.
So all I did was I just opened the bracket. This minus this, you have this. Sorry. So what I did is I opened the bracket. This will be minus. This will be plus. I just changed it. I put the positive front. I put the negative back. It's still the same thing. If I put it the same way, I'll still have the same answer. So that was what I did.
It was as in the S square minus the S square. That was what I was confused because I know that they will cancel out.
That is it, it's zero.
Yes, sir.
So I don't need to bother myself about writing the zero. Me, I just leave that one. I said, okay, I believe you know it's zero. So that was what I did.
Yes,
For
sir.
the one of the zero, I just leave it. Okay. Let's proceed. Let's f of s comma y equals to p vector I plus q vector j be a vector field. Now our R of vector of L equals to x I plus yj. So what is the R? X I plus the yj. So if we now have f dot dr would be implies that f dot dr will be what? What is dr? You know. You know your f. My f is p vector q field dot the s plus the y j. Remember when you dot the two, what happened? Our f dot the r will be equals to p dx plus q dy. So at the end of the day, I have my closed integral of c f dot dr equals to p dx plus q this is work done alone, work done alone. A is simple closed curve C through a vector field, which is W equals to integral C f dot dr equals to 0. F dot dr equals to 0. Then don't forget, which implies that integral of closed C p dx plus q dy is the same thing in this region, integral of integral dq dx minus dp dy, everything multiplied by dA. So all we need to do is we need to know based on the question and solve the problem. Example 2. Let's look at this. Remember, we are trying to solve the work done part. So we have this one, integral s cubed dx plus x y dy consists such that angle 0, 0, 1, 1, and 0, 1. So in this case now, we have our f of s, y to be x raised to the power 3i plus x raised to the power y j. So for us to draw this, there are certain things that occur here. Remember, this is our 1. This is the point whereby it moves to this angle. And at this point, our y equals to 0. S is also equals to 0. So we can begin to also fill it. So we have this one to be y, and 1, this is 1, that is y equals to 1, x equals to 0. Then at this point, we know that this is y equals to x or x equals to y. But now let's continue based on what the information we have. We can now go ahead and integrate this. If you want to integrate this, what do you have? Remember, integration of this curve, closed curve, is x raised to power 3 dx plus xy dy is equals to integral r. Who can tell us what would be inside this place based on the formula? Remember, the formula says the q dx minus the p. So this, in this case now, this is your p, while this is your q. So use the formula to solve it. This formula here. Use this one to solve it. So what do you have? It's very simple. Anybody? Good. So we have it to be y minus 0 dA. How many of us agree with me? Raise up your hand. Let's see. If you agree, let me see your hand. So if that means you don't know what I did. I don't care.
I don't know what to do.
You two don't know what I did. You know it, you don't know that it's the same thing I did.
I don't understand.
Okay, now let's go back to it. Remember what your formula says. Our formula said the q dx. This is the q dx. This is q. Did I say differentiate with respect to x? What do you have? You have y. Because s will be 1 multiplied by this will be y. The p dy. Do you have y here? No, you have 0. Because everything there is constant. You remember the law of partial derivative. Hello? Silence means yes. So we have it to be integral. The first integral will be y equals to 0 to y equals to 1. And s equals to 0, s equals to y. In brackets, y dx dy. Any question? Any question, please?
Sir,
Yes.
so it means the last part you wrote now is the answer. That's why you're going to stop from the
No,
equation.
you have to integrate it now. It's just, I'm just giving us, okay, listen, this is very simple. Don't look at the formula. See the formula that I circled. This part is your question given to you. So this is the formula. You solve this one within. Once you solve, you resolve the one Q, the S, the P, the Y. Once you resolve them, substitute it into your integral the way it is. And you know your dA is your dx, dy. We are talking about the area now. We are having the x, dy. So you can see the one I partially differentiated, I have y minus 0. So for me to solve this now, integrate this one with respect to, the first thing is with respect to y. If I integrate this thing with respect to y, what do I get? What do we get, please? So you are going to have integral y of 0 to y equals to 1. If I integrate this one, I will have x, y. To carry 0, s equals y. Everything dy. When you now substitute the value, remember we differentiate with respect to s first. When you substitute the value, you have y equals to 0, y equals to 1. Substitute this, you have y squared dy. Remember, 0 is so what do we have? Anybody? Integrate this one with respect to y. You have y raised to power 3 over 3, which implies 1 over 3. Remember, is 0 to 1. Is 5 over 3, 0 to 1. When you substitute it, what do you have? You have 1 over 2. 1 over 3, rather. You have 1 over 3. So, but I want you guys to solve this one before we call it a day. Just make sure you try it. Solve it. Integral C x squared y plus s cubed dx plus 2xy dy. And your part is this, part bounded. The part bounded, what do we have in part bounded? Y equals to x and y equals to x squared. We know that this is a quadratic. It's similar to the first example we had the other time. Remember that at this point, this is where y equals to x. This is external. Don't forget you have 0. Here you have 1. X also 1 to x. And don't forget the formulas. Formula says integral of p dx plus q dy is equals to dx q So can we solve this one? Can we try it? First of all, resolve what is inside. When you solve what is in there, substitute what is inside here. Then you can now begin to dissect it. Any question? Any question? Are we solving it? Okay, you try. Lazarus, Ifeanyi.
So let's solve it together now.
Are you solving it? Hello?
Yes, sir.
So what did you get in your differentiation? What did you take as your P? Anybody? What is your P in this case? Nobody. Look at the formula. Which one represents P from the formula? Anyone with the S is your P. This is your Q. The P, the question answered the P, the Y. The P, the Y equals to what? equals to y. Then the q, the s. The q ds is what? Two y. The p dy is x squared. So anyway, go and solve it. If you solve it very well, your answer will be 1/12. Any questions? You solve it very well, it's 1/12. Any question, please? On the what do you call your exam, please?
They have adjusted the timetable, so it's not that formal date against it.
Oh, so it's when now?
On the 9th. Next
On
week,
the
Tuesday. On the 9th, sir.
wow.